Good afternoon, everyone. 11.5 billion minutes of actions used on only open source projects last year. That is the amount of actions that are spent, action minutes that are spent on the GitHub platform, and that's only by the open source projects. Now, if you expand that even to all the enterprises that are using this, it even goes on and on and on and on. Welcome today in the session about GitHub Actions in Action, where I want to share with you on how you can get started on using GitHub Actions and much more. This session will be about not only how do you use actions, but also an opinionated way of implementing actions for your enterprise purposes. And why am I doing this? Because, the past 8 years have been an interesting journey if it comes to helping all our customers in the various industries staying compliant and making sure that they can do DevOps on the GitHub platform. We learned a ton of things, and what I'm going to share with you today is actually some of those learnings and the way we have learned to set things up so that you are secure, compliant by default if you implement it like that. So that's what I want to share with you today. My name is Marcel de Vries. I'm the Global Managing Director and CTO of Microsoft Service Line within Xebia. And Xebia is a company of about 6,000 people in size in 14 different countries, and I was able to co-found the Microsoft practice back in 2014. We're plunking away. We're now about 180 consultants specifically focused on the Microsoft practice, and we started in the Netherlands. We then moved into Belgium, then into Germany, and now we actually flew over to the United States and are there as well. So we have a nice team here helping many customers implementing GitHub, but also doing a lot of AI stuff, which I shared already many of the other conference talks today. I will go to the agenda with you. We will start with some foundational pieces so everybody's on the same page. Then I will go into CI, continuous integration, and then I will spend a ton of time if it comes to continuous deployment, CD. Okay, because I think, or we learned, that splitting those out is really important because CI is a different, I would say, duty, responsibility than actually the CD where you deploy to production environments, where there are some other things that you need to implement to make sure that it's compliant also with all kinds of regulation, and that's where segregation of duties comes in and all these other things which you can achieve just using action workflow runners. I will also go into some of the deployment strategies, depending if you're using, for example, web applications, Kubernetes clusters, etc., and how we can actually move from eventually your dev environment into a production state. So if we look at GitHub Actions, then actually the key functionality is that it's a workflow engine. Okay, so GitHub Actions is a workflow engine for anything that you're doing within the GitHub platform. A workflow can be run either on a Linux machine, a Windows machine. It can run in containers. If you like that as well, you can set up your own clusters where you will run that, which we call our own custom runners that we might have. You can also make use of the infrastructure that's provided to you by GitHub, where you just run that stuff nicely in the cloud. And there are also setups where you can run it in the cloud, but still in your private network. So there are some tricks that you can do there as well with Azure infrastructure. We also have a feature called matrix builds, which is specifically useful if you're doing, for example, Linux builds for different setups, different machines, different architectures. You can then set them up and say, well, I would like to do this kind of workflow, but I want to do it with these parameters and then with other parameters and then with other parameters, and you can then fan that out, and so that you have like multiple builds going on at the same moment in time. There's also the capability of getting streaming output, so you see constantly what the thing is doing. You get that input nicely in a console, and it has a built-in secret store. I will come to that if we're talking about how do you secure your deployments. If it's easy to write and easy to share, I'll leave that in the eye of the beholder. Who of you loves to type YAML? Yeah, exactly. So I'm also in that camp. It's like, yeah, YAML, brilliant. It's like, yeah, but whatever. Apparently, our industry has chosen to make life painful. So why not have significant white space in your text files, right? It's easy to let it be written by a co-pilot, so that might help you sometimes getting things done faster. When GitHub created the notion of actions, I'm not sure what they were drinking, but for some reason they had to screw up the naming from the get-go. Because we have the notion of GitHub Actions, which is the thing that is executed as part of a workflow, but we call the whole thing also an action workflow. So it makes life complicated if we're talking about actions. So I try to refer to my GitHub action workflows as like that's the whole workflow that's doing the work. And we have then the action itself, which is just one little thing that it can execute. For example, run a command or do a batch script or call into some machine to do whatever you like. Okay? We have the notion of workflow files. That means that we can create as many files as we want. We can put them, or we need to put them in a specific location within GitHub. This is the .github folder, and within the .github folder, there's a workflows folder, and that's where you store your YAML files. Now, if we look at how these YAML files are built up, then it all starts with an event, something that happens in the GitHub system. That can be almost anything. I'm filing an issue, I'm opening an issue, I'm closing an issue, I'm reopening an issue, I'm creating a release, I am updating a release, I am creating a pull request, I'm committing code, I'm creating a branch. All the things that are happening within the GitHub system are more or less automatable with this workflow engine. This is where you see a lot of the GitOps kind of workflows come from. Like everything that you do with GitHub, you can make it like your whole orchestrator of a lot of things. Within our company, for example, for the Microsoft service line, what we do is when we onboard people, we use a GitHub workflow for that starts doing all the stuff that's needed to provision accounts and get everything set up for people to actually onboard on our company. So you can use it as a generic workflow engine. But of course, you see that it's primarily built for continuous integration and continuous deployment. Now, once an event triggers, that is when we can then tie it to what we call a runner. And a runner can pick that up, and then a runner starts a job. Okay? So you have the notion of the runner itself. That's actually some executable that is running somewhere in the cloud or on your own private runner infrastructure. And then it will start a job. And a job can be on the same runner or it can be on another runner. A job is just a definition of what is the stuff that needs to get done. And within a job, you have then the notion of steps. And the step is actually an action. Okay, it's one action. And you can set up multiple steps, and those steps can have inputs and they have outputs. And those outputs can then actually be redirected either back to the runner, even to another job if you want to, so you can continuously communicate more or less between the different jobs that are there. Now the syntax for this is that you need to give it a name. If not, it will come up with a goofy name, so I advise you to give it a good name. And then you specify the event. This event is specified with the on keyword, and then you can say, okay, on what? And there is, like I said, a gazillion types of events. And here you see push is the event. But I make it more specific. I could do on push anything, so there would be a star. That means that if I push to any branch in my repository, it will trigger. Now what I stated here is a push to the main branch will trigger this particular workflow. Okay, so you can make that also with stars and slashes and those kind of things that you, for example, trigger only on feature branches or specific patch branches that you might make depending on your branching strategy. After we specified the event, we then set up, okay, what is the job that we're going to do? And the job needs to run on a type of infrastructure. So what we're going to do here, you see that the job has a name lint. And this is where it becomes a little bit confusing because lint is something that I could figure out myself. I could make that any name I like, colon, because that is the name of the job that we're running. Okay, you see that back in the logs, you see that back in the console. And then what you say is, okay, you give it a name, and it runs on some type of hardware. Now, there are predefined hardware setups. Those are in the cloud, but if you create your own, you name them so that you can then refer them in your YAML profile. So here you see Ubuntu latest. That means the latest version of the Ubuntu Linux distro that will then pick up this particular job. And then what will happen is the lint job will start, and it will then execute the steps that are defined. And you see that the steps that are defined here is uses actions checkout v2. This means that it will then execute the action that can be found, and it has a particular name, checkout, and it has a particular version. You see the @2 is version 2. It is tied to the versions that you can give to your releases. It is a good practice to always specify the version, because otherwise you will get the latest, and that can be something that is not really released yet. It just takes the repo that it points to. Because actions are actually something that you will find in a repository and that you can access and can look at. Okay, so I can create an action workflow, or sorry, an action, and that action is just nothing more than a public repo, and everybody can point to it and it will just pull from there. The moment I create a release, I can use the @ sign to pin it on a specific version number. Then you see it uses the GitHub /superlinter v3, and we specify that it's going to use the environment, and you see here GitHub _token. Every job gets a token assigned, and the token gives its rights to interact with GitHub itself. Now, normally that is only read-only rights, but you can specify on top of your workflow file what are the rights that you want to give to this particular workflow that runs. And that's crucial if it comes to security, because imagine that you see here that I'm picking up secrets.github token. This is an implicit variable that's always there that gives you the token of the current workflow that is running. But I can store my own secrets in a secrets vault. And then I can do secrets dot the name of my secret, and then that secret can be a token to Azure. It can be a token to some other storage or some other environment that you want to have access to. Now imagine that if somebody that has an action and that action has some malware in there, it could exfiltrate somehow, for example, your token and use that, right? So that's the reason you need to be very careful with what are you pointing at. Now, GitHub created this notion of a marketplace, and this is the marketplace on the public repositories in the internet. You can also create your own private marketplace if you want to. Some of the things that we do a lot for our enterprise customers, where we create a fork of all the actions that they actually want to use. We run those through security tools to make sure that there are no crazy vulnerabilities in there and other stuff. And then we point them to the local forks that we have instead of the public internet versions of that, so that we can then pull from that the moment we feel fit that we want to have a new version, instead of getting a new version every time that some committer commits something to its public repository. Okay? Now, the way we try to set things up, if it comes to continuous integration, is that there are a couple of things that you want to accomplish. And one of the things that I see a lot is that people create these large workflows that do everything in the kitchen sink. What I love to do is I love to segregate stuff out and know what is the purpose for the workflow and make it very explicit. So if it comes to my CI workflows, I often create a workflow that is really fast and gives the feedback immediately to my developer. Because the developer is in the moment, just created a commit and was like, boom, is it green or is it red? So what I will do there is only compile and perhaps run some of the fast unit tests that I have, but I won't go into work like, for example, packaging or security testing or quality control kind of things, or elaborate test runs that we do that might take a few hours. So I'm not saying that we shouldn't do that in the CI cycle. I just say that I normally put them in separate files, and I have separate triggers for them when I want that to be verified. So for example, when I say I want to create a release, that is the moment I want to run all these quality controls in there before I actually create the release that then would trip, for example, a deployment. Okay? So it's really important to have that notion that you are very diligent about what is the role of that particular workflow, and then tie it to a certain event that makes sense. Now let me talk just very briefly on actions and branching, because this is what I mean by creating purposely full workflows at specific moments in time. So when you are using GitHub Flow as a branching mechanism, which is this picture over here, you say that the moment I start building a feature, then I'm creating a feature branch, I'm working on that feature branch, working on the feature branch, and then at a certain moment I say, okay, I think I am now ready to push this to main, but before I do so, I create a pull request. That is the common way of doing that. And then after I'm creating a pull request, then I have my colleagues reviewing that work. So that's where you see the interactions with the chats that are going on. You make some additional iterations and changes, and finally go, okay, now push it to main. Now what I want to do is, at certain points, I want to have different workflows running. So I have the fast feedback CI cycles running the moment I'm doing these little changes until my pull request. Then the moment I do my pull request, I wanted to have a security review, and I want to do some additional code quality reviews on that. And perhaps then I augment my own pull requests first, before then my colleagues actually are going to do the work. The moment I push to main, that is the moment that I then want to create a release, because I want to release it to a production environment. And I also might want to create images or update my website with the documentation and all these other things. That comes later, right? So those are the different workflows that we might have. There's one additional one that I put there with a schedule on there, and that is the security scan. So the security scan always runs for me on a submit of the pull request, but it also runs on a time-based trigger on my main branch. Because you know what happens when you don't touch code? You still get vulnerable. That is because the industry is finding new ways to exploit the code all the time, so you need to keep track of that. And that's why we use that code scanning all the time, at least once a day. So fast feedback is as fast as possible. You do your basic validation and be done, and then you have the rest of the stuff that you're doing. Now, what I'm going to show you, there are a couple of demos that I have today. And what I'm using for this demo is a repository called Vries Marcel Globo Ticket. And let me go here, zoom in a little bit so it's a little bit bigger. So Vries Marcel Globo Ticket, if you go to that URL, you can go there. It's just a public repository that I have. And you can just try that yourself and use it. I have the URL also at the end of the session, so, and it's also in your decks. So what I have here is an application, Globo Ticket, and Globo Ticket is a demo application that we're using a lot for workshops that we're doing. So here you see Globo Ticket. In Globo Ticket, I can buy tickets online. I want to go to John Engelbert, 4 tickets, place the order, make some changes over here. I love this feature, by the way, that it already says save 25, then I get a discount. So that's a way you can then actually play around with this. But the idea is that we can use this as a showcase, more or less, how can we set up all these action runners and how can we make changes to this code, etc., etc. So Globo Ticket is the application that is running and it's part of this repository. And what I did is I created a set of actions for this. Okay? And you see here that I have an action that is called compile and test fast feedback. And if I look at this YAML file, you see it's in the .github workflows and then compile and test fast feedback YAML. You see that I created the YAML definition over here. I gave it the name 01 compile and test fast feedback. And here you see that I'm setting the permissions for the action token, by the way. The GitHub token that is passed here, I want to restrict it as much as possible. Preferably you don't give it any write access. What I'm doing here is I'm only giving it contents read writes, so it can read the contents from my repository. It cannot write to the repository. And I give it the permission to trigger another build. Okay, so that's why I have the action write on actions. And when I push either to the branch called feature star, that's the moment this would trigger. So if I create a feature branch of any name, then this build will trigger automatically. And this is what you saw, like the feature branch that I created, and then every time it will trigger on that the moment I push that to my GitHub repository. Then you see that I'm going to trigger only on these paths. So if you look at the code, and let me just show you the code over here. So you see that I have, for example, unit tests over here. I have playwright tests over here. what you often see is that, now, for example, a README file over here. If I edit this README file, I don't want all of a sudden trip deployment or anything else, right? So I restrict the trigger to be on branches that are feature star and only in the front-end catalog or ordering folders. So that's the way you can filter that. Now I say run on Ubuntu Linux latest, and then I'm using the checkout command. I set up .NET Core, so this is also an action here. And I can show you here, let me see here. So if I go to this location, so if I go to github.com/actions checkout v3, and it's giving me a 404. Why? There you go. So here you see all the action workflows that are there, just from GitHub itself. I will show you later that there are also ones that go, for example, to Azure, where you have like Azure repository where you can find all those actions. So I'm setting up .NET Core version 8. I'm doing a build. .NET build is just a command line that I'm running. Then I'm adding a markdown logger to this so that I see the results of the unit test. I will show you that a little bit later. The idea is that if you look at actions, actions is not like Azure DevOps, where you have the notion that it already understands that there are tests. But I would love to have a test report showing me in the screen how the build went and if the tests are completed, yes or no. So what I'm doing here is you can augment the build logs with markdown files. So what I'm doing is I'm saying, okay, as part of my unit test project, I am creating or I'm adding the liquid test reporter markdown that creates a markdown file from my unit tests. And then what I do is I do a .NET test. I get then the results.md file. And then I say, well, the output of that result, I want it to be part of my job summary. So what I'm doing is that I always want to report, otherwise it would not generate a report if I had a failed test. And then I say, well, just get me all the data out of the test results MD file and stuff it in this particular variable, environment variable. And if I do this, it will get picked up by the GitHub workflow and it shows up in my log. So if I go back to my actions over here and I would trigger this workflow, either by doing this, or what I could do is say, well, let's go to code, let's go to front end, let's go to my root, my style sheet. I have a style sheet over here, and I'm going to make an edit here. And what I'm going to do is I'm going to make the background. What's your favorite color, sir? Blue. So now we get a blue website. Change the body, background blue, great, thank you so much, Copilot. And then I create a new branch. I'm going to create a branch called feature / and then my patch. Propose change. And now when I do this, you see that I have a pull request over here, and I create a pull request as well. Now, if all is well, my action workflow now just got triggered. You see here, PR1. And that was caused by the fact that I created that particular change, okay? So this is the, oh, sorry, not that one. This one, change body background color from white to blue. You see this is the build, and now you see the streaming results here as well. So who is using Azure DevOps today? Yeah, then you're pretty familiar with this because it shows more or less the exact same way of running these logs. Now you see here that it's installing them, the additional stuff there. Always a ton of stuff in the logs. And then it's the checkout. Build is completed. Okay, good. So if I look at my build log over here, you see now that I have a test run over here. This is a report that I just generated with Markdown, okay? And I just attach this to my run, created with liquid reports, okay? So that's the way you create these workflows. Pretty simple, and you can trigger them on anything you'd like. So this is the report I just showed you. I put it here in the slides because you get the deck, so you can then use that also as a reference. But know that the way you get these additional reports and additional information in your build report is just by adding it to the variable GitHub step summary, and it accepts anything markdown, and it will just then push into your build log. We're constantly introducing vulnerabilities while doing nothing. So this is really important to understand. So for that, we would like to also have like a security control system in place. Not sure how many people know this, but GitHub has this notion of advanced security. And GitHub Advanced Security is part of the Enterprise Edition, by the way. You need to pay extra for the advanced security part. It has a couple of additional features for you that you can use. We use this all the time in the Enterprise because it has Dependabot. And Dependabot shows you what are the dependencies of your application, either in Node or in SQL or in C# or in any of the package managers that are out there. And the moment it finds a package that is known vulnerable, it will alarm you and say, hey, you ingested just a package that has a vulnerability, so that might mean that your software is also susceptible to a vulnerability. Now, the second thing that is there, and that's what the thing that I love most, is CodeQL scanning. And CodeQL scanning, what it does, it actually takes your code, it creates a sort of in-memory graph of your code, stuffs that in a database, and then you can run queries against that. And there are a lot of security researchers creating so-called CodeQL queries for us that then show that there might be a vulnerability in the data flow of your application. Now, all of a sudden, when you are creating or committing new code, while you are not aware of it, you might have just introduced a new bug or a new vulnerability. Now, code scanning is there to guardrail there for you that you're not introducing those kind of exceptional situations that are known in the industry to exploit applications. So if you make that code commit, it will warn you beforehand, like, hey, you know that you just created something which is, for example, logging in plain text a password or something in a log file, which all of a sudden can make you vulnerable, right? Now, you can also plug in all kinds of third-party tools if you want to, as long as it's reporting serif as a format. It's just a standard format for these vulnerability reports. Then that can be picked up by GitHub as well. So if you're using third-party tools, you can also add them to your GitHub workflows, and based on that, get those reports in. Now, I have already a scan running here. You saw, if I look at all the workflows, that I had PR1. You see here CodeQL. That is actually CodeQL running in the background for me. If I look at this, you see it's nothing more than just a set of workflows and the different jobs that are running there. Now, the nice thing is here you see security 19. This means that it found in code scanning a couple of issues with my code here. You see that I'm missing a cross-site script request forgery token validation, and this is a high vulnerability. So now what I can say, well, this is probably not good, so how can I fix this? Now the nice thing is that they have the button over here, generate fix, and it will just try then with Copilot AutoFix to create a fix for you on the fly. It will create a pull request that you can then take and then test it with your code base and then get rid of all these vulnerabilities. We've used this a lot with different companies where we ran these, I would say, bug rallies or bug bounty rallies with CodeQL and then created like, okay, now let's get rid of the highs and the mediums, and then the lows probably are good. And then get at least those vulnerabilities out of much of the public software that is being used. So CodeQL, I like it a lot, and it's just part of your settings over here. It is available, by the way, also advanced security for public repos. That's the reason I'm having it here. But you can then turn on the code scanning over here. Okay. And then the moment you do CodeQL analysis, this is then the actual workflow that is verifying if the code that you have been writing is correct and not susceptible to known attacks. We more or less covered the continuous integration part, because continuous integration is about you make a change, you want to integrate it into your branch, and if it's integratable, then it can be taken into the main line and then pushed to production. Now, the next step would be that the moment I then commit to the main branch, I want to create a release. And that's why I like that in the GitHub platform, there's this notion of a release. It's a built-in concept. And a release is something that has in the Git repository itself a tag that you can always trace in history, because Git history is always a traceable thing. It's immutable. And the nice thing is that the GitHub platform then surfaces that as a release. And in a release, I can also package files. I can say, well, this release contains these particular files, and those are the files that then are, yeah, something that I can set up to be released. So what I like to do is I normally like to create a workflow that creates a release for me. And that release then takes the code base of the main, packages it up into the packages that I need to deploy my application, then create the release and make those packages part of the release. And now I have an immutable unit that I can always trace. And this is really important if you are in high compliant environments, that you always have an immutable state that you can point to, like this went to production or this went to a certain place, and I have some 4 eyes principles in place or segregation of duties in place that I make sure that more eyes is on the ball before we get something to a production state. Okay? So this is why I like to use these releases. And if you're doing these releases, then you need to start introducing versioning. Because versioning is really important if it comes to which version is in production, or which version did we find a bug. Now, versioning is something that we have been, I think, dabbling with for years in our industry. But what I like is that there is this notion of semantic versioning, which is really a very nice way of defining how you should do version numbers. And we try to adhere to this standard more or less, okay? Because semantic versioning gives me the option to have a patch, a minor and a major version. And it helps me also decide if I can take in a new version without breaking changes. So semantic versioning is about, for example, the patch version. And the patch version, I'm incrementing the patch version only and only if I do not have any breaking changes to my code. So this is normally when you have like an internal fix or just a bug fix that you have or some specific condition that you're fixing. And the policy here is that the moment you have a patch version increase, it should be something that you can always take without breaking your code base. Now you also have the notion of a minor version. And a minor version is when we say, okay, the interface that we are using might have been changed, but not in a breaking way. Meaning that if I had an interface with, let's say, a class that was part of my package, and I'm using that class and it has a constructor. Now the constructor always will have the same argument. It will not have a different type or all of a sudden multiple parameters without falling back for the old interface. The example here is that you add some new features or you add like a new API call that you could do. But when you update your software, it will not break, but there might be a new capability all of a sudden available that you are probably not using. Now, the moment we are really going to make big changes, that's when we're going to make a major version. And major versions are a broken version. Broken in terms of you need to do some additional work. So the moment you see that the major version increases, that is the moment you know that you should actually put it on a backlog and have a team of developers look at it before you actually take the change and run some additional unit tests and additional tests around it to make sure that nothing has been broken. Okay? Often when you take these major version package updates, you will get like a compiler error or something that would break at runtime. Now there is an action that we can use to do the versioning for us when we're using Git as a repository. And that is called Git version. Now the Git versioning is done based on the history and the branching strategy that you're using in Git. Now what's nice is when you go to, let me go here. So if I go here, Git tools actions. So this is a nice thing with these actions. If you go to github.com and you then append Git tools actions, this is where the actions are located. Okay, so you see immediately the code base that is being used, and this is where you can find the tools and all the data, the stuff that is there. So this tool is something that I can use to determine what would be the version of my next release. And when I use the GitHub version branching strategy, it works out of the box. You can also use the Git version strategy, and there are multiple strategies that you can use. And you can configure that with a YAML file, of course. to set up in a certain configuration when it should increase which number. The way you increase a version number is just by adding a tag on your Git history, and then you can bump a version number, a minor, major, or a patch version. Now, the one thing that we need to do is the moment we then fetch the repository, we need to set the fetch depth to 0, which means infinite, meaning you get the whole tree out of Git. Because normally the fetch depth is 1 or 2, only the last nodes that it's fetching, but you need the full history to determine what would be the version number. It takes a little bit more time because it needs to download then the full repository, but that said, all of a sudden you get these version numbers out of the box. And then I can have an action, and that action can create a release. Now the action to create a release is then softprops action gh release. And again, if you just postpan softprops /action gh release, you will see the repository where this action is, and you can actually look at the code base there. Now, what you see is that I'm passing it in a token. The token is secrets.extended access token. You might say, why am I not using secrets.getup token? And it has to do with the fact that the standard token that is applied to your workflow does not have the ability to trigger another workflow. Because otherwise you could get into infinite loops, because it keeps triggering stuff, and you could like a trigger storm, you might say, and all of a sudden everything comes to a grinding halt. So that's by default, your token does not have the ability. Then when it makes a change to the repository, it will not trigger another workflow. So if I would do a commit here, and I have a trigger on commit, it would not fire. So what I've done is I said, well, in this particular case, I wanted to fire an event. And the event that needs to be fired is release created. And why do I need that? Because I want to trigger my release workflows, my continuous delivery workflows, based on the fact that I created a release. Because that is the full package that I now have that can be deployed to my test or the, production environment. Is that I'm now using then the end git version sem version. That is the semantic version that I got from the previous step. So in this step over here, I get that environment variable set in the environment, and I'm picking it up here as the environment variable git version. And what I'm doing is I'm saying, yeah, generate me release nodes. So what it will do is it will look at the previous release that we created and the release that we have now. And all the nodes are in between. It will pick up all the issues that were filed with that, or all the commit messages that were part of those commits, and we'll create a release report with all those commit messages. And now what I do is then add the files to the release, which are then in this particular case 3 zip files. My ordering, catalog, microservices, and my front-end web application, all 3 as a zip file, because I can deploy this, for example, to Azure Web Apps. And this is the example that I'm using. I could also say, well, I'm just only creating 3 YAML files. That would be the deployment file where I made a change to the name of the container so it can be deployed to a Kubernetes cluster. What I also then need to do is make sure that the containers are pushed before I create the YAML file. So if you look at the CI practices, we have the fast feedback, the code QL on the pull requests, we have the code QL time-based, and we have the notion of creating a release the moment I push to main. And then I'm going to move to the releases. So what I have in my repository over here is the create and release web apps. Create and release web apps. And what you see here is that I'm just checking out the repository, fetch depth is 0, I'm doing the .NET version, I'm installing the .NET version 8, I'm installing the Git version tool, then I'm determining the Git version, then I do a .NET build of the front end, I do a .NET publish of the front end, and I do the same for catalog, and I do the same for ordering. Now I'm going to zip up the artifacts, so I have the zip files that I want for my release, and then I create the release, and I hand it over the zip files. And this will create a version with the environment git version sem version. So now I create a release with the right semantic version, just as part of my standard commits that are going on. Now what I will do first is then I have a pull request over here, and what I say is this pull request, I am going to merge it. So now I will have my change that I just created as part of my main branch again. So it's merged, and then I can delete the branch. I don't need it anymore. It's good. And what I can now do is say, well, I just had this thing. You see, I pushed to main, so yeah, you see the code QL already running. I'm going to cancel that one because it's not relevant now. But my create a release, I can now say run this workflow, and now it will then create a release for me. So let me go back here. You see that my current release is 1.8. Okay, and what should happen is that in a few moments you will see a 1.19, and we can then have a look at how we're going to deploy those. If you look at this release over here, you see that it has the catalog front end and ordering zip file. So this is my immutable state with the nice commit messages. I can track the history, and I can also track the pull requests that came in with the comments. So I have my 4 eyes principle in there as well if it comes to an audit trail. Now then the question is, what kind of release can we do? What kind of deployment strategies can we have? There are a couple of ways of doing things. What I like to do is, I like to separate deployments from releases. You might say, what do you mean with that? Well, that has to do with the fact that how do we actually deploy our software and when do we release the feature to the end user? There's a difference in there. Now we'll get to that. So one of the things that we try to strive for often is zero downtime deployments. We don't want to have any downtime in production, although I still see that my bank goes on red every Sunday night or so and doing some deployments. I don't know why. It's 2026, come on, you could do better. But nevertheless, you should be able to do a zero downtime deployment. The idea is that this is possible as long as your applications are stateless, and you need to have some traffic management in place. And what I also prefer is that we then separate the deployment from the release, which is an extra step, and have observability in place. Now, before I go into more details, let me just explain a little bit about what I mean with a stateless application, because there seems to be some confusion around that often. A stateless application does not mean that it cannot accumulate state while it's processing its work. It can still accumulate state there, but the moment the request comes in, it did not know that a request was made before. And the moment it did all the processing and did all its work, when it returns, it either returns the state to the caller or it stores it somewhere else, so that the application itself is stateless and can be called on another node or another place and then retrieve the data from the other part. Now, if you have that in place, you can then separate the deployment from the release. And the idea here is quite simple. You say, well, normally what we do is we stop the traffic, right? And then we have like, yeah, you're not allowed to do any transactions now, which is a little bit the old way of doing that. Then we uninstall, we install, we start the traffic again, and we had more or less a release and a deployment in one. Because, yeah, actually deploying new software is also releasing the new features. But what I would love to see is that we say, well, instead of this, now let's put in a load balancer there or a router where you say, well, let's install version 2 on a separate node. Then what we will do is we move the traffic to version 2. We slowly drain the traffic coming from going to version 1. Then we stop the traffic on the other node and we uninstall that version. And now we had actually zero downtime because the customer doesn't know that you actually now have a new version of your software running. And then you install version 3 and you do exactly the same. That's the way you can constantly update your software, and this is how you can actually get continuous delivery actually in place, because you're continuously delivering to production, not by definition showing that to the end user immediately. Now, you can do this in various ways, and I just want to share with you how you can do it on the web, on, for example, Azure Web Apps and Kubernetes. If you're using Kubernetes, it's good to know that you get this behavior more or less by default. The nice thing is that if you have a new version of your container, what you can do is you can state, well, I have, for example, 3 replicas, but I want to do a rolling update, and I have a max search and max unavailable defined. Max search means I cannot have more than 2 additional containers running in the total mesh of containers. And I cannot have zero availability, meaning that otherwise my application would stop to work. Now, if I do this, what will happen is it will deploy then a new pod version 2, which is not healthy yet. It's still in the state orange. I start a pod version 2, which is the second one, so max search is 2. so I'm creating the second one. Then the moment one of these becomes green, the load balancer understands that it starts moving the traffic there. And then it cleans up one of the containers. Now it can then start another one. The other one becomes healthy. Traffic goes there. It can kill the other one. And that's the way we actually had a full zero downtime deployment as part of a Kubernetes cluster. Nothing more than this state definition that you need. And yeah, the pods are taken offline when the new pods are healthy. Okay? Yeah.
How do you handle that when you have breaking change?
Yeah. So the question is, how do you handle this when you have a breaking change? There are specific ways of doing that. The breaking changes, what you normally need to do is then the dependent systems need to be updated first that can handle version 1 and version 2 of your system. So if you do that first, so you update the dependent systems first that can handle both with the breaking change, then you deploy the broken change version, and you flip the switches on the other one so it will go to the new version. And then you can do a second deployment on the other ones so that they are healthy again. So that's the way you do a breaking change. That's also how you can do it with schema changes in the database. You always then deploy something that can adhere to schema version 1. Then you have a deployment version 1 and 2 of the schema. Then you change the schema, and then you have version 2 of the schema. So if you have a little bit more advanced step here would be that you would say, well, I'm installing version 2, but version 2 has like a special place in there where there are still old software and new software in there, but we hide it behind a toggle, a feature toggle. Now what we're doing is we're then deploying the traffic, or removing then the traffic to version 2, but the old code. And then I monitor the behavior on version 2 first, and that's actually the best way of doing it, because then I can see if the old thing that I bring up still behaves in the same way, because there might be something else in the system changed why I have all of a sudden transient errors. Then the moment I then see that it's going well, that is the moment that I release the feature. So that's actually the feature toggle that I switch, and then I again monitor the behavior of version 2. And when that is all okay, that is the moment I actually switch the traffic off to the new version. And this is the most safest way of doing these deployments, but it requires that you also have like a feature toggle framework or something in place as part of your software development environment. Now there's another way that you can do these deployments, and that's what we call ring-based deployments. And ring-based deployments are an interesting way to solicit feedback, I would say, of actually production systems in a way that your system is really under load, but not by definition by all your customers. What you do is you place customers in different rings, and if you are a company that is using their own software, you are always in ring 0, so that you as a company know that immediately. Now, you release to one ring at a time when you do ring-based deployments. And then you move from ring 0 to ring 1 to ring 2, ring 3, and then finally all the rest. So that's the way you spread more or less your code across the different nodes. Now the question is, how do you define those rings? And this is, by the way, a picture of the Netherlands. And in the Netherlands, you see that I just have various places where I can deploy my software. And you can imagine that this is not the most smartest way to do a deployment if I would do something like this. Because now the whole region is then taken out. So what you should do is you should place those rings then also geo-spread in an environment so that you have a better way of detecting where errors are coming from, and you only have a few customers impacted the moment you have such a change. Now, we can do these deployments to also web applications. And for that we can use, for example, web apps in Azure. And web apps in Azure have a supporting feature called a deployment slot. Not sure if you heard of that, but it's actually more or less that you get the second node more or less for free. It's not for free, it's actually the same machine, so be careful there, because don't start load testing on the new thing and then all of a sudden, hey, my production is going down. Well, that has to do with the fact that it's the same machine. So that's not a smart move, but you get an isolated environment where you can deploy a new version of your application. And the nice thing about this is that the load balancer is built in. So with traffic routing, we get traffic routing as part of our deployment slots. And underneath the covers, there's a load balancer in there, and you can just use this question mark XMS routing name and then the name of the slot to move traffic to a particular slot yourself. So what you could do is you could deploy this and say, hey customer, can you try the new version of this, and then send a URL. And by sending this URL with this question mark and the name of the slot, you move that particular instance or that particular request to that particular slot, and then it can be tried. And it becomes sticky automatically, meaning that it will go to that particular environment. Unless the slot is deleted, then it will go to production that is already production. Now, a safe way of setting this up with web apps is that you normally create a deployment slot, then you deploy to the deployment slot, then you verify your code base, then you stage it and then say, let's go 10% of traffic in there. And then the next step is do 30% of traffic and monitor the behavior if it's okay or not. And then finally you do the virtual IP swap so that production becomes staging, and then you kill the slot. And that's the way you then are 100% all of a sudden in production. Now the question is, how do I deploy to such an environment? The best way of doing that is using OpenID Connect, which is actually you create a trust between your GitHub repository and your cloud provider. It's supported by AWS, it's supported by Google, it's also supported by Microsoft on Azure. And by creating this trust, you don't need to store those secrets. Actually, the moment the trust level is there, you can do deployments on those environments, and it will get like a temporary token, and it's immediately invalidated the moment the workflow is done. It's a much nicer way that you don't need to keep secrets around. It's the safest way that you can do, but it requires quite some setup of admin to make that happen. Now the other way around is using the secrets, and you store them in the secret store. And the secret store, we can use then the secrets dot, and then for example Azure Credentials is the name of the secret that I have. And then I can use the Azure login action to log into Azure, for example. Now the moment I do this, everything in my workflow after the login will work in the context of the login that has been done. It's the same if you're on your own console and do an AZ logon. You get some authentication going on, and then you can do your stuff on the command line after the fact. So these are the secrets. Then what I want to do is I want to pull down the release. So imagine that I have a workflow that is triggered by creating a release. Then what I can do is I can then get from the event the ID of the release. So there is a variable, just part of the event, just a property of the event. I can ask that, and I can use the action ds altares fetch gh release asset, and then it will pull that released version from my GitHub repository. So now all of a sudden I have then my zip files on my disk that are part of that particular release. It's a very nice way of segregating the duties, right? You have your CI CD, a CI first, you create a release, the release will trigger the eventual workflow, and then that workflow will pick up only the zip files and not the source code, just the zip files, and those zip files get installed. And then I create a slot in Azure. So AZ web app deployment slot create. I give it a name, use a resource group of course, and a slot name, and then I can start installing there. So then you do a deploy to web app action, and you give it the zip file that you just unpacked on the disk. And then what you can do is to say, well, now it's been deployed, so this deploy action has the ability to give you output, and the output is the location where it installed it so that you have a URL available. Now what you can do is in your workflow, you can define that you want that as an output parameter for a next job that will run. And the next job that will run would, for example, verify if the web application is up and running or not with, let's say, a playwright test or some other verification mechanisms that you might have. Now, one of the things I want to emphasize when you do this, it is important to understand that you build in some observability into your application so that you can observe the behavior of the thing that you deploy, so that you know if it's healthy or not. Most of the time I see that people just create like a simple web application test or something like that, but actually it would be much nicer if you have the telemetry available and just pull the telemetry from, for example, OpenTelemetry, and then see if things are well. When we started to work with Kubernetes and containers, we also got introduced to something that is used by Kubernetes and that is now also available in Azure Web Apps. And that is the notion of a health endpoint. And that health endpoint is also part of .NET. So you can very easily create those health endpoints. and then you have the lively endpoint and the ready endpoint. Ready means, am I ready to accept traffic? Lively means, do I still process requests? Don't make them the same. I often see that people make it the same, but if lively, for example, what I see is that lively probe often then says, well, the database is offline, so I will signal that I'm not alive. Don't do that, because the database was already not online. Now you're also killing your pod, so restarting the pod, and the database is still not there. So you get like all kinds of restarts and all kinds of stuff going on. Really look at if your application is still doing what it should do, and don't fail on downstream errors that are there. Now, the other thing that you need to do is look for the absence of errors, because sometimes we are only monitoring if there's like a 500 server error or something like that. You should really watch also the memory, the CPU, the cache hits, the I/O that is all over there, because to give you a little bit of an example, this is a log of a deployment that we did, right? On the left-hand side, you see the website that is just running perfectly okay. And you see on the other hand, the website that completely came to a grinding halt. But if you look at what is going on there, you see that the total CPU is spiking. You see all of a sudden that the requests are going up. And you see that my call durations are all of a sudden very long, in the seconds. But if you look at the red lines on the right-hand side, no errors. So this is why you need to monitor more than just the fact if you have a 500 server error or an end user error in your system. Now those health checks, they are part of .NET Core. You can have the readiness probe and the liveness probe. And starting .NET Core 2.2, it's just the use of these ASP.NET Core packages. Okay. What is nice is that you then can do builder.service.eld health checks, and then you get the endpoint, and you can then say, well, if my lively probe is at this endpoint, you can then query that. What you normally do is you map it to /health. That is more or less a standard that, for example, also Kubernetes looks at. It is good to know that if you look at this observability, there's a distinction between logging, which is analyzing unexpected behavior more or less after the fact. There's also this notion of tracing, where you want to follow a call through the call chain in your application. And for this, we often use the W3C traces. And this is also often a standard part of your infrastructure. You can also have metrics, which is more real-time system indicators and a constant amount of data that is being pushed, like your CPU or your memory pressure. And then you can do monitoring with, for example, Prometheus, Grafana, or Azure Monitor, or anything else that you would like. Okay, how can you add this to your system? You can use a service mesh for this. If you're running in a Kubernetes cluster, you can use Dapper. I'm not sure if you heard of Dapper, which is not the ORMer, but Dapper, which is actually an addition to your application that serves, for example, all these health instrumentation things. And in .NET Core tracing, there's a lot of stuff already available. But I can really say, please add this telemetry to your systems. Now what I have done is, to my web application, I added this health endpoint notion. And you see here that I created a very simple curl script where you see that I'm doing curl -s of the home page. Remember the variable that I just passed out of that particular action? I'm handing it over to this job. And now I can use homepage /health/ready if my web application is ready to accept any data or any requests. And then you see that in the environment variable, homepage is set to the deploy output homepage. So that's the way you tie these variables to each other in the workflows. You can also run playwright tests very easily. Just run tests, .NET test, and then test.playwright. You just give a standard C# project to it, which has playwright tests, nothing special. But really, really good stuff to work on. Nowadays, by the way, with AI, you also can have a little bit of a YOLO testing, I would say. And it's like you give like, can you validate the homepage, and I want to buy one item, and you feed that to an AI, and that AI will then drive the playwright tests for you. So you don't need to script it out all yourself, which is kind of cool. Now, the final part I want to get to is that we also want to have environments. Because if you deploy everything to one place, you want to be able to trace, was it in staging or in production or somewhere else? Now, GitHub has the option to create environments. And an environment gives you the option to do approvals, meaning that you can say, well, the moment I just deployed to this environment, it needs to be approved by someone. And I can approve by someone, make that a team. And a team can be variable, so meaning that the team, somebody in that team needs to accept the fact that the deployment was made. And the moment it says okay, you have again the segregation of duty in place to have like a release gate before you go to a certain next environment. How many of these environments you want is just up to you. They're just a string name, and then they are tied into the GitHub system where you can then define these approvals. And people get an email like you need to approve something, you click on the link, you go to GitHub, you say approved, you need some text there that you actually approve it. It's always looks good to me, right? And then move on. You can also do the time-based release, which is more for the ring-based deployments, because when I deploy to an environment, I can then say, well, wait for another hour before I do the next step. Yeah, so that's the way you can delay those deployments. When an environment is not there, but you refer it in your YAML file, it will just create it. And the nice thing is that you have secrets per environment, meaning that you can use exactly the same part of the workflow, but then by pulling the secrets dot, and for example, the Azure key, you can go to another subscription or another environment because you are using different credentials there. It's referenced in the same way, and you can also protect it from particular branches. So you can say, this environment can only be deployed to from main. That way, you prevent that it comes from a feature branch, for example. This is the way secrets work. So you have a cascading effect of organizational secrets. They are overwritten by repository secrets, and they are overwritten by an environment secret. So depending on where you define the secret, it will pull it from. Now, how do you move the traffic then from one environment to the other? Well, what you do is you just set the percentage using AZ web app traffic routing set. So this is how you set up the routing, and now you say, I am accepting 10% of the traffic. You see that I create an environment staging 10. You see that I do the Azure logon with the secrets again, and then you see that I'm doing the AZ web traffic routing set, and I set this to 10%. Then you see here my environment settings. You see that I have a wait timer there. I want you to wait 5 minutes for the traffic to start doing its work. And one of the things you can do is you can have set up a monitor on this and say, hey, if it's not healthy anymore, I want to stop this deployment. So you can just cancel the workflow at that point in time. Staging 30 over here, you see the distribution is now set to 30%. Actually the same kind of work that I'm doing there. Then finally the VIP swap. So I am doing the virtual IP swap. I swap then production and staging. And then finally, of course, you want to clear the routing rules. So AZ web traffic routing rules clear. And that's the way you clean up after you're done. I have the full demo in this repository. Let me show you. So if I go to global ticket and I go to actions over here, you see, by the way, over here that I now have a release 1.9, which was created 23 minutes. So I was talking about releases for 29 minutes after the last demo. You see that it now has the full change log of everything that has been changed, change the body background color, and I have the pull request merge here. You see the full pull request here as well, so you can have like who has been working on this and all the traceability that you need in terms for compliance. And then you see the assets over here, which are the zip files. Now in the action workflow over here, you see that I have the deploy workflows. I will go to front end because that's the most elaborate one. And what I did here is I said, well, first we have a job deploy. This job deploy will then set up the staging environment. It then uses it outputs the variable homepage, which is the deployed URL where I deploy to. And then you see that I am fetching the release based on the release identifier that I have from my event. You see that I do an Azure login with my credentials, and then I create a deployment slot, and I deploy the web application, and I deploy only the front-end zip. Then you say that I set the homepage variable. So I say echo. This is the way you actually push this variable into something that can be used in the next job. Okay. Now then you see that I have a validate stage, and the validate stage is then again staging. I do a checkout, and I am then running this script over here to see if the health endpoint is there and if it's healthy, yes or no. Then if it's healthy, then I install Playwright. I run my Playwright tests on the machine, and then based on that, I can also have a report, more or less the same way that I did it in my CI. I could also output a test report as part of my log if I wanted to. Then you say move the traffic there. Moving the traffic there 10%. I do the AZ web app traffic routing set, and I do again and ensure if the endpoint is healthy or not. Then the second step is then 30% or 20%, and I check the health point, 30%. I'm very cautious here. And then I do the VIP swap. Okay? And then finally, if everything is done, I clear the routing rules and I clear the staging slot. Now, when I have done this, that means that now my full deployment is done. So if I am going here, I should be able to see my environments. You see my deployments over here. The deployments to production, they succeeded 25 minutes ago. You can see what is been released to production. You can also see what has been released to staging. And you can set up all these different environments as you want. If you go to your settings, you can see the environments over here. So you see that I have production and staging. You see that you can set up the wait timer here. You can set the required reviewer so that somebody needs to review this, and after that it will then continue on. And you can protect it on branches. So set the protection rules so that you can only deploy from, for example, the main environment. Now, you saw that my actions all succeeded. So you see version 1.9 has been deployed for ordering, front end, and catalog. So I have a new version of my application running here now. So if I would go to the home page, I should be able to see that now I have the blue version. Okay, so that has been completely deployed. If I look at the workflow itself, let's go to front end, this one. You see that I have the different stages over here. Okay, so you see that I have deploy. You see the URL here that was created. This is now not accessible anymore because I cleaned up that environment. But in the meanwhile, while this workflow is running, this is a good endpoint. Then I validate. So if I go here, for example, to validate, you see that I'm doing the install the browsers, and I'm, let me see, validate the endpoint here. So you see here that I'm waiting for the health endpoint. What I did is the health endpoint that I created in my application, after 4 tries, it will say healthy. Okay, that's the reason I'm always seeing 4. You have a question, sir?
Yeah, I didn't see what happened if the playwright tests failed.
Mm-hmm.
I didn't see where that happened. I also didn't see how you took the zip and did anything with it.
Oh, okay. So let me show that over here. So if I go to the actions workflow release of the front end, I am picking up from the release here the zip files. Okay, so I'm using this particular action with the release identifier, and I'm getting all the files and I'm putting it on disk. And then I log into Azure, I create a deployment slot, and then I deploy the zip file. Okay, so that's the way we control that. And if it comes to the Playwright tests, they are over here. So here I install the browsers. Here I do the build of the Playwright test project. And oh, it's correct that you didn't see the results because I commented them out. I'm not sure why I did that, but probably because it took too long or it failed last time. But this is where how you run the Playwright test. Yeah.
I had a question. So, what if you talk about rollback strategy?
Mm-hmm.
Because we have some slots and some of our
Yeah.
some we don't. And some we just release from QA to prod.
Yeah.
And if we get to prod and we find that some of the smoke tests in prod didn't pass,
Yeah.
we roll it back. But that's been clunky.
Yeah. Yeah, so your question is more or less, what about a rollback strategy? But actually the way we have set up our release, rollback strategy is nothing more than keeping the traffic on the old version. So what I'm doing is I am installing a new version, moving a little bit of the traffic there. The moment I see problems, I just switch back. And I do a new install of the other one. By the way, that is not really a rollback. It's just continuously keeping your old version until you're 100% sure that you can roll forward to the other one. What I'm doing with the deployment there, by the way, is I also not rolling back. I just do a new install of a new version that has the patch in there. So I sometimes jokingly say rollback is for chickens. We only do roll forward if you do continuous deployment. Okay, but that said, with data, there's always some form of rollback that is necessary, but that is more or less the idea. And that's why we do the traffic routing, because that's the most safest way of falling back very fast without creating havoc. And because that rollback normally takes a lot of time. Yeah? Question, sir?
So if your new deployment has schema changes in the database, so I've got that old database, new database, so putting leaving traffic on old version, switching traffic to new version, but it's got new schema, it's doing something new.
Mm-hmm.
How do I then reverse back?
Yeah. So gentleman here asked like, okay, I created a new version, and the new version created some havoc in my database, right? And now I'm rolling back or moving back. Well, this is the moment that we also have segregation of duties, and you ask your DBA to fix up.
That wasn't quite the question.
Oh.
Is I've introduced new functionality
Yeah.
in my new version.
Yeah.
Requires those changes.
Okay, yeah. Yes. But if it comes to new changes in the database, then you need to have a different scenario. So the scenario that I just showed you works if there's no breaking change in the database. If there's a breaking change or a schema change in your database, what you need to do is you install first a version that understands both schemas and the new functionality. Now, what you do is then you switch to the new version of the schema after you made the schema changes, so that your existing version that is now in production that understands version 1 and version 2 of the schema can move there. And then, if something goes wrong, yeah, then you have a real problem, because then the data is, yeah, skewed.
Because like customer A happened to be on old version, customer B.
Yeah. Yeah, but so this has more to do with how do you design the change. And if you design a change for zero downtime, you need to be very careful about how you do these things. But normally what you see is then that you say, well, I can live with the fact that I have two tables, table new, table old. The old version will still inject in the old table, the new version will inject in the new table, and then you have like a new implementation that comes after that will start cleaning up the old table and moving it into the newer table. Okay, but it's a complete specific strategy for that particular change that is required, and that needs design up front if you want to make it zero downtime. So it's not as easy as just swapping around like I just showed you. So database schema changes and breaking changes often require you some more thoughtful process around this, but you can keep the infrastructure as is, you just try to solve it with multiple releases that you do. Okay, you do multiple releases of multiple versions that understand multiple versions of your application, and by that, you can get a zero downtime deployment. Yes. Okay, I want to share with you a discount code if you like. I wrote this all down in a book together with my friends Michael Kaufman and Rob Boss. We wrote the book GitHub Actions in Action that has this, like I said, opinionated way of doing things, but this is based on our work for the past 8 years with enterprise companies using GitHub, okay? It works really well in highly governed environments. We have withstand multiple audits on multiple levels if you want to have this in place. So recommendation, yeah, use perhaps what we learned over time. And you can find the repository that I have on github.com Vries Marcel Global Ticket. That has all the samples. If you have the book, there's also a pointer to a complete website that has all the samples in there, because I got like, I think it's something like 40 different workflows that we have that we go through in detail. If you like to learn more about a lot of the stuff that I've been talking about here, I'm also a Pluralsight author. Shameless plug here for some of the courses that I've done. And the latest courses I've also done is, for example, debug and troubleshoot code with GitHub Copilot, because there are specific ways to doing debugging and troubleshooting with GitHub Copilot, which is very nice and gives you up and running very fast. And the other one that I did is secure development of code using GitHub Copilot. There are certain strategies that you can use to write more secure code when you have these agents doing all the work for you. And that is also in that course. Of course, everything that I showed you today is also on there in one of my courses. And I want to thank you so much for your time, and I hope you have a perfect, great rest of the conference. Thank you.